Fun with Ferro Fluids, a presentation by Tim Lyons. Today we're going to make a magnet from an inkjet toner. So using basic household items, we're going to see how a fluid behaves when it attains magnetic properties. The supplies we're going to need are a laser jet toner, a rare earth magnet, some vegetable oil, and a glass container. And this is the process. First, we're going to put 50 milliliters of toner into a glass container. We're going to add 2 tablespoons of vegetable oil. We're going to stir it until it attains a smooth, thin consistency, not letting it be very thick. And then we're going to test the fluid with a magnet through the surface of the glass container. So, this experiment didn't work out particularly well for me. I took it and I was not able to purchase a bottle of inkjet toner. So what I did was I took an inkjet cartridge and drilled a hole in it and poured the ink out. I was able to get a fair amount of ink. I mixed it together with a little bit of vegetable oil, and I don't know if either the magnets weren't strong enough or the fluid itself did not contain anything, or was missing an element that would make it work in this experiment. But I tried several different magnets, and I actually tried several different inkjet toners. This was probably my most expensive experiment, and unfortunately it didn't work. You can see here on the right, I'm actually holding a magnet underneath the fluid, and the fluid didn't respond in any way. However, let's talk about what a ferrofluid is. A ferrofluid is a colloidal liquid made of nanoscale ferromagnetic or ferromagnetic particles suspended in a carrier fluid. Ferrofluid is an amazing liquid that follows the field of a magnet and becomes strongly magnetized in the presence of a magnetic field. NASA actually designed the first ferrofluid in 1963 in order to power rockets, because the fuel could be drawn into a pump by a magnet when it was in the weightless environment of space. In here we said it's a colloidal liquid. Now that's actually a term that I had to look up. What is a colloid? A colloid is a mixture in which one substance of microscopically dispersed insoluble particles is suspended in another substance. In contrast to a solution, a colloid has a dispersed phase, the suspended particles, and a continuous phase, the medium of suspension. A solution, on the other hand, has a solvent and a solute that actually combine, so they are in a single phase. However, colloids do not settle, or they take a very long time to settle. A good example of a colloid is milk. So what makes the colloid inkjet toner magnetic? Well, a substance called magnetite. Magnetite, which is Fe3O4, is one of the main iron ores. It is ferromagnetic, meaning it's attracted to a magnet, and it can be magnetized to become a permanent magnet itself. It is the most magnetic of all the naturally occurring minerals on Earth. And when it appears in nature already magnetized, the naturally magnetized pieces are called lodestones, and they were familiar even to ancient peoples. So why do they use magnetite in inkjet toner? It's used as a triboelectrification agent, which is a fancy word for static electricity. Triboelectrification is a type of contact electrification in which certain materials become electrically charged after they're separated from a different material with which they were in contact. This is required to have the printer particles stick to the paper. And that's it. So when we put a magnet underneath the ferrofluid, it typically is supposed to make shapes like this, which are just the magnetite in the fluid following the pull of the magnet, that the magnetic force that's flowing through the liquid. And that's it for my experiment today.